2.1b, angles in standard position. A rotation angle is made up of two rays with common endpoint called a vertex. It's the corner here. It doesn't have to be two rays, it could be two line segments or two lines or even planar surfaces. The two rays are called the initial arm and the terminal arm. The initial is where we start and the terminal is where we finish, and we know the difference because we're going to have a direction arrow to show which way we've gone. If the angle is in standard position, the vertex is at the origin and the initial arm is on the positive x-axis. Positive angles are rotated counterclockwise, and negative angles are rotated clockwise. Now, angles could be in standard position and be larger than 360 degrees or smaller than 0 degrees. And depending on the size of the angle, the terminal arm could be in any of the quadrants, 1, 2, 3, or 4. You need to be able to read these Roman numerals up to 4. So 1, 2, 3 is pretty easy, and 4 is just C1 minus 5 here. Now they go like this. This is quadrant 1, this is quadrant 2, this is quadrant 3, and this is quadrant 4. Sometimes the terminal arm could be on the x or y axis, and those would be called quadrantal angles. A reference angle is the angle formed by the terminal arm with its closest x-axis. It's always the x, never the y. Just remember, you always go back to your x. It is always stated as a positive angle and must be greater than or equal to 0 or less than or equal to 90 degrees. Let's try this. Sketch each angle in standard position, which means we need an initial arm at 0 here, or the positive x-axis, and then our terminal arm will be at 175 degrees away, so something like that. Now I need a direction arrow to show which way I've gone, and I also want to write down what the reference angle would be. The reference angle is in between the terminal arm and the x-axis, the nearest x-axis. So it would be right in here, and it would be 5 degrees. Let's try this one, 40 degrees. So our initial arm is here. Our 40 degrees would be something like that. So this would be 40 degrees, and that's actually our reference angle as well. So our reference angle is the same as our angle here in standard position. Negative 120 degrees. So that means that we have an initial arm here, and we're going to go back this way. So that would be negative 120 degrees. Our reference angle is found on this side because that's the nearest x-axis to the terminal arm. So theta reference is 60 degrees, and always positive. It doesn't matter if it's above or below. We just want this angle as positive angle. Next one, 90 degrees. So here's our initial arm, here's our terminal arm, and well, that's 90 degrees, and our reference angle will still be 90 degrees. Which way did we go? Did we go this way to get our reference angle or this way? It doesn't matter. 600 degrees. So we have our initial arm here, and this time we're going around, we need to go around 360, and then 180 more will give us to 540, and then we need 60 more, so we actually end up somewhere over here like this. And we need this direction arrow because then we know which way we've gone and that we've gone a whole rotation around before we got here. The reference angle here is 60 degrees because in between here and here is 60. Angles drawn in standard position that have the same terminal arm are called coterminal angles. The smallest positive angle, coterminal with a given angle, is called the principal angle. So the principal angle for this is 135 degrees. The reference angle is 45 degrees. And this 495 degrees would be coterminal because without the direction arrow, these would look exactly the same, which is why it's so important to use that direction arrow. Name a positive angle and a negative angle that are coterminal with 300 degrees. So 300 degrees is down here in quadrant 4. So a positive angle that's coterminal with that would be like 660 degrees. A negative angle that's coterminal with that, we could have gone backwards instead. So that would have been negative 60 degrees. A ship is sailing in a direction given by north 35 degrees east. A lot of questions have this type of direction, so let's see what it means. North is the direction that they're taking their measurement from, and 35 degrees means that they moved from north 35 degrees towards this direction here. So let's see where that would be. So we line our 0 degrees up with north, and then we look 35 degrees towards the east direction, and that would be here, here. So drawing our graph, or drawing our angle, looks something like this, and this right here would be the 35 degrees east from our initial heading of north. Our reference angle for fun here would be 55 degrees. This is part of Trigonometry 1, Demonstrate an Understanding of Angles in Standard Position. Here's some questions. See if you know what you're doing.